In this video, we're going over the Math 1 Practice EOC explanations for problems, 46 through 50. Alright, it says, Robert, again, if you haven't noticed, this problem is in a different font than the other ones. The problem that was originally here is no longer on the test, so I supplement it with this one. This is a question that could or could not be on the test, so we'll just go from here. Robert takes medicine for an ear infection. There are 250,000 bacteria present when he begins taking the medicine, and 35% of the bacteria are destroyed every hour. 35% are destroyed. How many hours will it take for 70% of the original bacteria to be destroyed? Okay, so a lot of different percents going on here. The first thing that hopefully you're doing is writing your equation, and you remember that it's the y-intercept times your growth or decay factor raised to the x. Well, my starting amount is 250,000 bacteria, and 35 is being destroyed every hour. Okay, so that's decay. And it's always what? 1 minus my rate if it's decay, or 1 plus my rate. Since this is decay, it's 1 minus, so 1 minus 0.35 gives me 0.65. So 35% is leaving every hour, and 65% is staying. Now, the question said, how many hours will it take for 70% of the original bacteria to be destroyed? So the next thing I needed to do was say, okay, well, what's 70% of the original? So I times this by 0.7, and that gives me 175,000. Well, if this is destroyed, what would be left? So 250,000 minus what would be destroyed, and you are left with 75,000. So I need to figure out after which one of these hours am I going to have about 75,000 remaining. What I did was I plugged this into my Y1, and then I went to my table and I recorded the values for each of my answer choices. So for 1 hour, you would have 162,500 remaining. After 2 hours, you have 105,625 bacteria remaining. After 3 hours, you're going to have 68,656 bacteria remaining. After 4 hours, you have 44,627 bacteria remaining. Which one is the closest to 75,000? B, 68,000. Okay, for 47, it says the number of points scored by a basketball player in the first 8 games of the season are shown below. What would happen to the data distribution if she scored 24, 22, 27, and 28 points in her next 4 games? Okay, so there's lots of different ways you could have done this. What I did was I plugged this into my L1, and I went to statistics, and I said calculate 1 var statistics, and I wrote down some information. Then I went back to my L1 and added these values in and said calculate the 1 var statistics again and compared them. So for the old, before you add anything, I recorded the mean, the standard deviation, the min, my Q1, median, Q3, maximum, and my IQR. And those values were 24, 7.17, 15, 17, 23, 31, 35, and 14. And then I went back in, added those other values, and recorded it again. So min, Q1, median, Q3. Remember, IQR is my Q3 minus my Q1, max, and my IQR. And my new values were 24.42, 6.05, 15, 19.5, 44.5, 29, the max was 35, and my IQR was the same because it's Q3 minus Q1. No, it wasn't. Sorry, oops. So I've got 29, minus 19.5 is 9.5, sorry. There we go. And the only other thing that I did was I wrote down that they both have the same range. So max, minus, and min, same range. The next thing I did too, which you didn't have to do, is I kind of I went, once I got the data, I went and graphed it in the scatter plot. And when I did that for the old, I'll have to do this really small. I graphed it as a histogram. I used the histogram feed from the calculator, and it looked like this. And then after I entered the new data, I went and graphed it again, and it looked like this. Okay, which helped me a lot because I had a picture of it. It said, what would happen to the data distribution if you scored this? So it becomes less peaked, more widely spread, less peaked, less widely spread, more peaked, less, etc. First thing we'll look at is widely spread. That has to do with range, standard deviation, IQR. Okay? If you notice, your standard deviation went down, the IQR went down. That means the data points are getting closer together. So it's not going to be more widely spread. When it says more widely spread, I can go ahead and take those out. That's definitely not going to be it. Okay? When I look at my histogram, I can tell if it's going to become less peaked or more peaked. Well, the data's getting closer together, and you can see from my histogram picture that it's getting more peaked. So my answer is C. 48. Whew. This one is also very extensive. The table below shows the shoe size and the age of 7 boys. Approximately what % of the boys' ages is more than 1 year different from the age predicted by the line of best fit to the data? Cool, so a lot of steps. The first thing you had to do was plug in the data for L1 and L2 and calculate a line of best fit. And you should have gotten something close to plus 4.097, which I just rounded to 4.1. Okay, this is my line of best fit, and I use the calculator to do it. If you don't remember how to match me, I'll show you the calculator steps. From there, I used that, and I just added onto my table what the predicted should be for each kid using the line of best fit. And this one was 10.88. The next was 10.88 also. Then it was 12.01. Yours might have been a little different, but should have been very close. 13.14, 14.27, 15.4, 17.66. Then I added another column and I said, yes or no, was it more, greater than 1 year different than what it should have been? And so the first, yes, 10.88 is bigger than 1. When you subtract the predicted column minus the age, if it's bigger than 1, then it's a yes. That's what I did for each one. Then it says, what % of the boys, so out of my 7 boys, was 1 more different? 1, 2, 3. So 3 out of 7, which is 0.428%, which is 43%. Again, that had a lot of steps to it. 49. The scatter plot below shows the number of arithmetic errors 10 students made on a quiz and the amount of time the students took to complete the quiz, which describes the relationship between the number of arithmetic errors the student made and the amount of time it took to complete the quiz. Well, hopefully all of you already know that this is what? Negative. Anyone that says positive at all, those are definitely out. Okay? Are the dots close together? Yes, I almost ran through all of them right there. So this is definitely a strong negative. Okay? Strong means they're close together. That one is B. And the last one. An elevator can hold a maximum of 1,500 pounds. 8 people need to use the elevator. Bill had some measures from the data set of how much each person weighed. Which measure would be most useful to determine if the people can safely use the elevator? Okay? Well, this one, they're not really giving you any numbers to play with. You really have to know what these words mean and the effects they have on the data. So, keyword here would be most useful. Okay? This, you should rule out. This is no-no. Okay? How often somebody's weight occurs is not going to help us. That is a bad choice. The next that I would rule out is my median. Why? Because this is my middle number, and it doesn't account for outliers. Okay? It doesn't tell me if I have any outliers. If we're all getting on the, if we have these 8 people, and one, you know, everybody's ranging between 100 and 200 pounds, and all of a sudden you have somebody who's 375, that's not going to show up in your median, but we need to know that because they're going to throw this off. We might get our maximum. Okay? So I need to know if there's outliers. The median does not show me outliers, and that's the problem. Now, this is a measure of spread, how spread out the data is. Okay? This is just taking my Q3 minus my Q1. So this is my upper median minus my lower median. Again, this is not really going to account for outliers. It's a better idea than B, but it's still not going to tell me if I have someone who weighs, I might have someone who's really underweight and who weighs 75 pounds, or I could have somebody who's 400 pounds. This is not going to tell me that. What will tell me is what? The mean. That's going to give me my average. The mean is affected by outliers. Just like if you have a bunch of hundreds on your quiz grade and you make a 0, that is going to pull down your average, your mean. Okay, so A is the best answer. And that's it.